Good day everyone. Thanks CSCE for giving me the opportunity to present my research. The title of my paper is A Framework to Evaluate School Infrastructure Project Need Using Fuzzy Expert System. I myself is Manjul Hassan, a PhD student at the University of Alberta. Ross Newton from Alberta Education is co-authoring the paper with me. Let's look at why we need to build school projects. Here, I'm showing a heat map of student population growth from year 2001 to 2020 in Edmonton region. We see student population has increased significantly in this community. Therefore, we need to build schools to address evolving capacity needs for this growing student community. Sometimes, school projects become necessary due to the changes in regional demographics and boundaries of a particular jurisdiction. For example, Lethbridge School Division has recently revised their school boundaries to alleviate some pressure from the existing schools, which may trigger the need for a new school in this region for future. We also need capital investment to rebuild old schools, recognizing the need for an improved facility to provide a 21st century learning environment to the students. Definitely, nobody wants our kid to go to such crappy school that I'm showing over here. So, what kind of school projects we should invest in? Definitely in new buildings and renovations. Sometimes it can be renovations with right sizing of the facility as well. Last year, Ontario government invested $500 million to build 30 new schools. Alberta government announced $397 million in 2019 for 25 school projects. The British Columbia government announced funding of $339 million over 3 years to support the kindergarten to grade 12 education system. So we understand school capital investment take a great chunk of money in terms of capital investment of a government. Maintaining and building new infrastructure is crucial for promoting sustainable economic growth. Capital projects for infrastructure Capital investments for infrastructure projects are large and funding opportunities are often limited. Therefore, in order to achieve the highest number of positive outcomes, capital investors, like the government, need to prioritize the project based on the criticality of the need. However, the core question remains the same: how to select projects? When making decisions regarding the funding of school capital projects, it is also imperative to simultaneously compare it with other capital needs. For example, roads, refineries, hospitals, utility services, etc. Therefore, assessing the need with quantifiable terms for any school capital project is deemed critical for decision making. In this paper, we propose a methodological approach for a consistent and transparent way of quantifying a project's need and scoring the project accordingly. When I say scoring, that means prioritizing the project accordingly. A fuzzy expert system has been developed to automate the process of assessing the school project's need. The major advantage of using such fuzzy expert system is that it can handle both the qualitative and quantitative variables within the same model simultaneously. So, what is the model structure, or what are the input variables that I have considered, and how we came up with those input variables? The input variables for this model are identified by conducting a series of semi-structured interviews with 3 professional experts who has over 15 years of experience in planning school capital projects. The participants were asked to provide a comprehensive list of parameters and their definitions that can be crucial for evaluating the need for a school capital project. A total of 18 parameters were compiled from the interviews. After the interviews were completed, a comprehensive list of the parameters along with the definitions was sent to the participants once again, and they were asked to assign a relative score to each parameter on a scale of 0 to 10, implying the significance of each parameter. Average scores were calculated for individual parameters, and the parameters that received an average score of 5 or above are considered in the development of the model to predict the school project need, which is the output variable of our model. After identifying the main input parameters against the output variable, the model is structured further by putting the input variables into groups and subgroups under common theme. These groupings have made the model more organized and condensed the set of rules for persuading it to a fuzzy expert system. In this slide, I'm showing you the membership functions for each input variables that we have generated from experts' input. In the development of this model, we used if and then rules for limited data availability. The modified version of the approaches proposed by previous researchers has been adopted to generate the fuzzy expert rules. While doing so, we considered the input parameters are independent and have an equal effect on the output. And the number of rules should be equal to the multiplication of the number of membership functions for all input variables. Case study. A total of 5 projects are used for evaluation, and the input parameters for each project were summarized in this table that I'm showing over here. Then the model developed in this paper that I'm presenting right now is used to predict the need score for each case, and corresponding linguistic variables is used to describe the need. So if I say the score is 93.28, the need in linguistic term is high. That is how we evaluated the project need. The forecasted need scores of the model are compared with the expected needs predicted by the experts. When the need scores falls under 2 membership functions, the maximum strength of the membership function is used in comparison. According to the comparison result, the model can accurately predict the right scale of need in linguistic terms. Considering the membership value for all expert decision is equal to 1.0, the accuracy of the model was around 98%. Conclusion. This paper presents a comprehensive framework for evaluating any new school project need in quantifiable terms based on the fuzzy expert system. The notable contribution of this paper is that we try to formalize a methodology to identify the essential variables for quantifying the project need, and we also have shown how to use those variables in assessment of school capital project need. Even though proposed framework is developed in the context of the Canadian environment, the method presented can be applied as a general framework worldwide for evaluating the school project needs by any authorities or agencies. These researches Primary limitation is that the model is formulated using a limited number of experts who have work experience within the same public agency. So there can be some bias in terms of that. And no correlation analysis among input variable has been done due to a lack of data. That's the end of my presentations. Thanks for your attention. If you have any questions, please feel free to ask. And here is my email address.